Welcome to March 4th LeetCode Challenge. Special positions in binary matrix. Given an m by n binary matrix called mat, return the number of special positions in mat. So a position ij is called special if the matrix at index I, index j is equal to 1, and all other elements in row I and column j are zeros. The rows and columns are zero index. So we have a special position in, let's see, both the row and column have to be has to have a unique 1. So if you look at this example here, given this matrix, you see that this 1 here is a special position in the binary matrix because both the row and the column is uniquely only has one value of 1, the rest are zeros. So if 0, 0, 1, and then you have 0, 1, 0, and this is a special 1. Therefore, it has returned the output is 1 because it only has one special position. If you give this example here, all the rows in the diagonal are special because they are the only unique ones in both the rows and the column of that specific index. And therefore, you return 3 because there's 3 unique positions. So let's say that m is the length of the matrix, n is the ith index of the matrix, the length. Both m and n are between 1 to 100, and each index I and j, it could either be a 0 or a 1. Alright, let's kind of see how we can solve that. So the first thing we want to do is probably scan the matrix and see whether we could find a special one, special position. So in order to do that, let's initialize it. So say m will be the length of the matrix, and we have n to be the matrix at index 0, the length of that as well. So that'll be the column size, length. All right, let's go do that. So initialize both the row and the column size, and next thing we want to do is get the array. So we say call it the row, new index of size m, and index array called columns, new index of size n. Alright, so we initialize that. So the first pass, let's call it that, will be to count is in each row and column. Count ones, I should say. Okay, and then let's do a for loop for that. So for index I equal to 1, I equal to 0, I should say. What the? We are going to iterate through I less than m, increment I by 1, and then we're going to do another for loop for index j equal to 0, such that j is less than mn, and we shall also increment I by 1, j by 1. Alright, we do a nested for loop, and we scan the matrix. So if the matrix at index ij is equal to a 1, then we should probably keep track of that. So say row at index I will be incremented to 1, and columns in index j is equal to incremented to 1. So the first count is to basically count each ones in each row. That's for now. And we exit that for loop. We should initialize a result. So initialize a result equal to 0. And this is the second time. We're going to do a second pass. And this time we're going to check to see if each one is special. For index I equal to 0, where I is less than m, increment I by 1. Same thing, we scan the matrix doing a nested for loop, so index j equal to 0, where j is less than n, increment j by 1. Alright, next receive a special. So the matrix at index ij is equal to 1, and the row at index I is equal to 1, and the columns at index j is equal to 1, then our result is unique. Our result is special. So we can increment that by 1 too. Alright, and then we exit this for loop, return results. Alright, let's take this for a spin. So if this works, oh, let's see. So we have a nested for loop here. Success. So that means that time complexity wise is m by n, where the worst case outcome is m times big O m times n. Since these two for loops are in parallel, then they don't add to time complexity together. Space complexity, it's actually less space complexity because we don't store any of the indexes in memory. We were to use it. Obviously, if we were to have so it's basically m big O of m plus n for space complexity. And yeah, that's pretty much it. Have a good day.